Okay, normally when we have regular lectures, we have plenty of practice exam questions and quizzes, and we have a few now, so this is going to be good practice for you guys to go over the quiz and make sure that you know the answers and can write out the answers without looking at your book or notes, because that's when you really have command over the material. So let's go ahead and write a key for this quiz, and it shouldn't take me too long, but let's go ahead and give it a rip. So when we got to write a mechanism, we're going to want the structures of the reactants. So hydrobromic acid, HBr, nice strong acid, so this is probably going to protonate something. And then 1-ethyl cyclopentene. So the ene means we have a double bond, pent means we have 5 carbons, and cyclo means we have a ring. So we need to draw a nice 5-membered ring, which looks like an upside down baseball home plate. We're going to put a double bond somewhere, like that. And then on the first carbon, which is one of the ones with the double bond on it, we're going to put an ethyl. So there we go, hydrobromic acid with 1-ethyl cyclopentene. And with the final exam and the 4th exam, the first thing you want to do is evaluate what types of reactants do I have and how can they possibly react. Now, one of the few things we've seen alkenes do is have addition reactions. So if you see an alkene, you'll ask yourself, hey, can I add something to that? And if so, like if you have a hydrohalic acid, then you would look at this and say, hey, this is going to be a hydrohalogenation reaction, and it's going to go like most addition reactions. So the addition reactions we've seen have often been catalyzed or reacting with strong acids, and the way that'll work is the double bond electrons will go grab the H+, and the bonding electrons in the acid will become a lone pair. So when that happens, we'll get the bromine turning into a bromide. And then with the double bond, we have 2 different carbons. One of them has the ethyl group on it, the other doesn't. So the hydrogen can bond to either one of those. So that's where we have 2 potential pathways for the reaction. Very exciting. One of them is going to put the hydrogen on the same carbon as the ethyl. Draw that in there, and that puts the carbocation on the other carbon from the double bond. The other one is going to put the hydrogen on carbon number 2, as we call it. So this is number 1 and number 2. Hydrogen can either go to number 1 or number 2. If it goes to number 2, then it puts the carbocation on number 1. So here's our 2 possible carbocation intermediates. Again, this guy having electrons was looking for positive charge, so nucleophile. This one, being partially positively polarized, was looking for a more negative charge, so is the electrophile. So there's the first step, protonation of the alkene to yield a carbocation and the halogen anion. Then we go to the next step of the mechanism, and now the bromide is going to be reactive enough as a nucleophile to trap the carbocation. So we have a plus there, ethyl group there. If this bromide goes and bonds to that carbocation, then we end up with cyclopentane with the bromine on one carbon and an ethyl group on the other carbon. And then if we have the bromide react with the other possibility, same type of mechanism. The bromine is going to be the nucleophile, which makes the carbocation the electrophile. If you're positive, you like electrons, so electron-loving carbocation, electro-loving carbocation is going to grab the bromide. So the bromine lone pair becomes a bonding pair to connect to that carbon, and we end up with the addition product where the ethyl and the bromine end up on the same carbon. So one of these is going to be 1 bromo, 1 ethyl cyclopentane. Right, we don't have the double bond anymore, so it's a cyclopentane. Now we have on the first carbon both bromine and an ethyl group. This one, because of the alphabetic superiority of the bromide here, one of these dots became detached to the bromine, so try to clear that up a little bit so you can see there's 3 lone pairs on the bromine. It's a good thing to review your work when you get to the end, make sure it's making sense to anybody that would look at it. So now this one has a name. Call this carbon number 1 because it has the alphabetically superior group there. 1 bromo. And if you wonder what I mean by that, bromo starts with a B, ethyl starts with an E. So I'd call it 1 bromo, 2 ethyl cyclopentane. So you can see all these parts of the name describe something that we've identified before. So first step of the mechanism, addition reaction, hydrohalogenation. First step of the mechanism is protonation of the alkene to give a carbocation intermediate. And then the second step is the nucleophilic attack of the bromide or other halogen to the carbocation intermediate to form the final product. The other thing that we might want to mention, which is really important here, is the major pathway is the one to the more stable tertiary carbocation. So the major pathway leads to the major intermediate. The major intermediate leads to the product that we get more of. So we're going to get more of the 1 bromo, 1 ethyl cyclopentane. And so hopefully all this made sense and you nailed it on the quiz. If you didn't, it's a clear sign that you should study a little more for the final so that you can nail it for the final.